Stability of floating bodies. Figure 9 shows a body floating in equilibrium. The weight W acts through the center of gravity G, and the force of buoyancy Fb acts through the center of buoyancy B of the displaced fluid in the same straight line as weight. So this is the situation that we described just now. Let's say we have an object like this. So and then we have a center of gravity here. So center of gravity here is the centroid of all the object here, whether it is submerged in water or not. Center of gravity or centroid for the whole object will remain the same point. And then because half a part of this object submerged in water, so for sure it displaces certain amount of volume of water in this area out to another place. So because it displaces certain amount of water here, so it will create force of buoyancy, and force of buoyancy will act through the centroid here. But you must remember the centroid for force of buoyancy, it is also known as center of buoyancy. It is only the centroid for the submerged area. So mean the red dotted there is the centroid for the red shaded area here. So this is the difference between center of gravity and center of buoyancy. And then if an external force acts on this edge, so it will rotate the box here like this one. So and then what happened is the center of gravity will remain the same because it is center of gravity for the whole object and it is for the weight. However, for center of buoyancy here, B1 here will change the position from here, from this position into this position. So it is because the center of buoyancy or the centroid of the where the force of buoyancy acts is actually depend on the submerged volume. So this location is actually the middle point to separate the right and the left volume of displaced water here. So that's why the center of buoyancy shift to the right. It's because it's need to balance the volume of the submerged area. When the body is displaced through an angle theta, as shown in figure 9b, W continues to act through G. The volume of liquid remains unchanged, but the shape of this volume change and its center of buoyancy move relative to the body from B to B1. Since the force of buoyancy Fb and weight are no longer in the same straight line, a turning moment is produced. Figure 9b shows the righting moment and figure 9d shows the overturning moment. So this is the righting moment and this is the overturning moment. So the righting moment means this moment could help this object to return to its original position. However, for overturning moment here, so it will not return the object to the original position, but new position will be developed. So for this one, so we will call it is stable because the object capable to return itself to the original position. So and then how to determine or how to know whether this situation is stable or not. So let's say we have a box like this one. So and then we have a gravity here. So in first condition, before any external force acts on this box, so the axis for gravity is vertical like this one. So and then a force acts at this edge, and then it will incline like this one. So and then the axis of gravity will remain like this one. So we assume that this axis is not changed. So and then the center of buoyancy move from this point to this point. This is the new point for center of buoyancy. So we draw a straight line pass through the center of buoyancy, and then we found that the intersect point here is above the gravity. So we call the intersect between the gravity axis and the buoyancy axis is M, or metacenter. Okay. So and then for this unstable condition, again, so we have a center of gravity here. So and then we draw the axis of gravity like this one. So and then if we push this object to the left like this one, so it will floating like this one. So and then we need to remain the axis of gravity as previous condition. So means that the axis of gravity will incline like this one, and then we draw a vertical axis pass through the center of buoyancy. So we found that the intersect point here is below the gravity. So you could see that the gravity is here, and then the location of M is here. So in this situation, we found that M is below G. So but in this situation, we found is M is above the G. So then we could make conclusion that if the location of M is above the G, so it will create a stable condition. So if the location of M here is below the point G, so it's create the unstable condition. Point M is the point at which the line of action of the force of buoyancy Fb cuts the original vertical line through the center of gravity G. The point M is called the metacenter. The distance gm is the metacentric height. From figure 9b and d, it can be seen that if point M lies above G, a righting moment is produced, equilibrium is stable, and gm is regarded as positive. If point M lies below G, an overturning moment is produced, equilibrium is unstable, and gm is regarded as negative. If point M coincides with G, the body is in neutral equilibrium or stable equilibrium. So this is the basic idea to determine the position of metacenter relative to the center of buoyancy. So we need to plot an axis on the object based on these 4 items here. So we need to determine first the origin of our axis. So and then we need to determine the center of buoyancy. We need to determine the center of gravity, and then we need to determine the location of metacenter. If the metacenter is above the center of gravity, so the position is stable. So the word GM here, for example, we have a BM here, and then we have a GM here. So the GM and the BM is actually a vertical distance. So BM means the vertical distance from point B to point M. So and then GM means the vertical distance from point G to point M. So to determine the distance, so you just calculate like this one. For example, we have a G here. So you just draw a horizontal line here. So and then this is the M. So just draw the horizontal line here. So and then the GM means the distance, the vertical distance from this point to this point. So it is not a distance from here to here, but it is distance from in vertical in y-axis from G to M, and BM means distance from this point to this point. So and then I would like to introduce with you three basic equations need to be remembered to solve the problem of stability and buoyancy. First is Bm, mean the distance, the vertical height, in y direction, from point B to point M. So we make it simplify it as Bm is equal to I over volume, which is the I here is the second moment of area. So I is the moment, and here is the volume of the submerged area. So and then we could calculate Bm is equal to Bg plus Gm. So you could see from here. So Bm means the distance from center of buoyancy to metacenter is equal to Bg, the distance from center of buoyancy to center of gravity, plus the distance from center of gravity to the metacenter. So this is just about the distance, the vertical distance from point B to G and to point M. So and then the distance Bm is known as the metacentric radius.